So a short introduction. My name is Wenhu Tang, and I'm Prime Manager in Ericsson. And today I will talk about this multicast broadcast market and also the evolution to 5G. Oh, how can I change the slide? Can you see next screen or just 1 second? Yep. Can you see the second screen? Second slide? Yep, I see it. So basically, first, before we look into the 5 MBS, or we call the multicast and broadcast services in NR, which I introduced in release 17, I think we should look back to see what is happening before that, and basically LTE, EMMS, and also what is happening here and now, and the lesson we learn. And these high-level slides showing that the journey we're having actually for LTE broadcast. So we basically, there are 3 waves for the LTE broadcast. First wave, we start from the 2014. Operators in US, basically they start the live TV broadcast commercial services. Initially, focus will be the live event, as exactly as you mentioned, a stadium, and then it's mainly for sports game and also live concert. For example, they could have a 3-day concert and broadcast in the major stadiums, and also the most popular actually end user feedback is that they can do the video replay, exactly what you mentioned actually. And then after that, and the operator expand the services to broader geographic area. For example, they can broadcast live video services nationwide, and like the weekend, the sports games, which they have the content right to deliver them in the mobile leg. So that's quite important. It's mainly for operators who have content strategy. Basically, they are provide premium content to their subscribers, making sure that they can retain the servers and also with a very small fee, and then they can get premium content. So that's basically one driver for such operators. And also, they also do some a popular TV shows push to the devices. For example, as you mentioned, the popular TV content, even advertisements, clips, etc., to monetize the services. And also, even some operator did the live 360 video broadcast for some concert for trial. So that's the first wave, and the main feature in the first wave we see from our customer is that it's really this multicast on demand. Basically, the seamless switch between unicast and broadcast for the live video broadcast, which is already supported by LTE EMS. It is quite mature. And then the second wave is for the EMMS or LTE broadcast is mainly the mission critical communication. It is defined by SUP since release 13 that to achieve this KPI required for the large group mission critical communication, for example, push talk, you have this requirement to reach all the group members within 300 milliseconds. For example, this voice to air delay. Before between you push the button and everybody until everybody's hear it, you have to be less than 300 milliseconds. So that means that you have to ensure that QoS, which EMS, when you have a large group of people gather in the large incident area, many firefighters, and also policemen gather in places. So that's why EMS is a must to ensure the QoS for this kind of life-saving services. And then there are operators is also trialing the mission critical video. For example, you have this drone video broadcast to the firefighters on the ground, making sure that the people on the ground can really know the fire is coming, and then basically reduce the casualty. This pretty much second wave, and then the third wave is also happening, but it's mainly trials. It's about the massive device. It's more machine-to-machine update. The typical use case is software update, for example, to the devices, IoT devices, or connect cars. So that can really reduce the OPEX for car company to to do the recall of the fault, for the fault. And also some case like the broadcast, the popular advisement to the billboard. But these the third rates mainly in the trial phases. So this you can see here along the way, it's really operator and unauthorized rider in the driving seat are driving the ecosystem to evolve, and the device actually is also grows with the use cases grows along the years. So that's basically the lesson learned and from use case point of view from LTE stage. Then from technical point of view, what lesson can learn from deployment of LTE broadcast and the EMS in the LTE? So here I list the three major lessons. Of course, there's more than one lesson, more than that actually. These are just a three example. The first one is about the RAN configuration. The lesson learned is that it is take quite a big OPEX for operator to really set up and configure a single frequency network, basically to making sure that you have a good QoS and optimize the configuration. Sometimes you even need the manual work and especially the coverage assessment to have a proper MCS configuration, etc. And also this dependency between the RAN configuration, MCS configuration, and also this efficient layer for error correction configuration, it makes things even more complex. Of course, Ericsson have tools available to that. So, and then second, the lesson learned is exactly the point the other participant mentioned here. One of the main pain point operator want to have is really to optimize the major traffic in the network. Typically is the over-the-top application traffic. For example, video traffic, which require agreement between operators and the service provider and the content providers. Mainly because the typical OTT content are typical TCP protected. So to really switch between unicast and broadcast, you have to have an agreement in place, and that's in itself is quite a big roadblock because it's quite hard to find a sustainable business model between the operators and the OTT providers. Of course, it's case by case. And third lesson we have is that this IP multicast routing support is required to enable the LTE broadcast. And it is normally not enabled in the private network, and it also takes some effort to enable it in the operator's network as well. So that could be a roadblock for the operator to deploy a broadcast multicast services as well. So that's the three lessons we have, and we believe that we should keep it in mind. And when we consider the next steps, we'd say the 5G multicast and broadcast. Then what's new then in release 17? In general, our view is that the NR multicast and broadcast in release 17 is totally different animal, basically, compared with LTE. They're quite a big difference. Here I list 5 items. I will pick a few of them, talk about it. And the first one is unicast and the broadcast and multicast. So in LTE, the end-to-end services it transmits either by unicast or multicast, and from the server to the core network to RAN to UE. The choice between the unicast and the multicast actually it is made by the server. It's quite a higher layer. Well, in NR is this end-to-end the service always transmit by multicast when the file MBS is used, and the choice between the point-to-point or point-to-multipoint, I mean unicast or multicast or broadcast, it is made by RAN. So it's more efficient and it's more dynamic. So here I put here this LTE is more semi-dynamic. Basically, an NR basically is a dynamic configure per cell. So that's the benefit of NR. Of course, it's introduced a bit more complexity. And also in the LTE, this session continuity between during mobility and also between unicast and broadcast is not really specified by GDP. But NR it is clearly specified by standard, so it's going to be standard solution. And also in NR, it improves this UE feedback and HARC retransmission, because it is not supported in RT. So for EMMS and NR, you are able to, for example, have this UE feedback and HARC retransmission for point multipoint in the RC connected mode. So it is more advanced. It can really give better QoS for the premium content, for example. And for the last one, this idle mode and EACT mode, I think is I refer to the slides on the right. In release 17, we have this two mode defined. One is called multicast mode. Basically, you need to join the sessions, the multicast broadcast sessions, to receive data, and then the session is received by in the connecting mode. But this data will only transmitted when there is a UE join the session, so it's more spectral efficient compared with the broadcast. Broadcast mode is actually, you need to join the session, but the spectrum will be carved out anyway. So that's the drawback, so to say. So that's in general the short overview of what is available in release 17 and the multicast broadcast. And then the next step for the evolution to the 5G, what we see is that the major benefit is really about the spectrum efficiency, because the use case is quite similar. And actually, most of use cases we can already achieve with LTE broadcast. For example, this productivity and as I mentioned, the mission push talk to the large group peoples. And push video, this body cameras with drones cameras, and push data, and also this MBB like this live video broadcast in stadium and data broadcast, cache media, and V2X is also not new. And of course, with NR you can have better latency, and also this IoT file download cases as I mentioned. So, but with NR multicast, the solution will be more dynamic and the spectrum efficiency will be much better. And then this last slide is about ecosystem, and we're looking at for the release 17. So I think basically we should learn a lesson. And if you see the slides, the picture on the right, it's an end-to-end impact and to really have the ecosystem growth. So start from the enabling technology, for example, the support on the chipset and middleware. Because that's really the foundation for us to have a good device penetration, which is key for the business case for operators. And with that, and then we should also have the support from the end-to-end solution stakeholders, for example, the device OEM, like Apple, and also the application server and client vendors. They should switch on, and there's a support for multicast, for example, and to use the multicast interface and northbound, and also the RAN and core vendor as well. And with that, and then the operator and the service provider can have a good foundation to deploy end-to-end solution and then make good business. But based on the lesson learned, actually the operator and the service providers actually are on the driving seat to drive the ecosystem. And so basically what we want to highlight here from the left-hand side is that we believe that we should ensure we have a global scale ecosystem to avoid this have local isolate solution, because that will really limit the size and then potentially impact the operator's business case to have a successfully services for multicast. And also the service provider or operator are really the drivers. Based on the lesson learned from LTE stage, it takes many years. Start from the first initial commercial services until you have a sizable device support, etc. So, and also add with more use cases. So it's operators really need to expand upfront, and then they drive the ecosystem from the device chipset and middleware to the server, etc. And also the recommendation we have is that we should maximize use of existing asset you have. For example, we see some operators, they are leveraging the existing LTE lag, for example, the EMMS in their non-standalone setup to have such multicast services at first step, and then they can learn from their field experience and then grow to adopt new technology like the 5G multicast or broadcast in later phases. And the last one is, as I mentioned, we really need to have a sustainable business model, end-to-end, to make sure that the major stakeholder have a benefit. For example, the lesson learned we have for the typical OTT and the service provider partnership require. And the curve here, the multicast and broadcast, the mainly reason why we show this curve is because we see that there's some customer in market showing interest on the multicast as the first step. And as you know, that this release 17 just finalized, so it's still in the early phase for the ecosystem development. So the operator are also exploring right now. Yes, that's basically it is. So hand over to you. Any questions?